Hey everyone, today we are starting with a new FPGA series using the Efinix Titanium Ti180 M484 development kit. So, this isn't going to be a what is an FPGA series. Instead, this series is about getting hands on with the board, bringing it up, testing it, and then gradually building our own designs. So, today we'll first take a look around the board, power it up, verify that everything is working, make sure we are ready for development. And in the next videos, we will start with LEDs, push buttons, and eventually move on to UART and RISC-V embedded flow. Alright, so before powering anything up, let's take a quick tour of the board. If you see right here in the center, this is the Titanium 180 FPGA. This is the device we'll be programming throughout this series. And right here, if you see, this is the USB connector, USB 1. This connects to the onboard FT2232H chip. We will use the single USB connections for JTAG programming, SPI flash programming, and later UART communication as well. And right next to that, we have the 12-volt power supply jack. And also we have PSW1. This is a switch to power on power supply for the board or switch it off. So So if you see right here, you see user LEDs. These are LED 2, LED 3, LED 4, LED 5, LED 6, and LED 7. And these are onboard user LEDs. We will spend a lot of time with these in the next few videos because LEDs are probably the quickest way to know whether your FPGA design is actually working or not. And right next to that, you see two switches, SW3 and SW4. These are user push buttons. So one interesting thing is that they are actually active low. So when you press them, the FPGA actually sees a logic 0 instead of 1. And then we have SW1. This is the reset button. So this is the FPGA configuration reset button. If you ever need to reload the FPGA configuration stored in flash, this is the button we will press. And here we have another button. This is for resetting the USB connection, FTD, resetting the FTD that chip. And then we also have a SD card slot. And then uh, and then and then we have FMC connector here. This is J5. So this is the FMC connector. Using the FMC to QSC adapter, you can connect expansion boards like HDMI, Ethernet, MIPI, LVDS, and more. And we also have P1, P2, P3, and P4. These are high-speed QSC connectors. They are mainly used for daughter cards such as camera modules and other high-speed interfaces. Uh, and finally, you see over here, this is J9. This is for external programmer. This is a 10-pin JTAG header. If you ever want to use an external programmer, you can use that. So, all right, let's power this board up. So, so let's turn on the PSW1 switch here. So that completes the board bring up. We will have powered up the board and verify that it's working. And in the next video, we will see about how it is communicating with the Efinity software. And in the next video, we'll start writing our own FPGA design. So I'll see you in the next one. Bye. Alright, now that we have verified our hardware, let's move on to the software. If you haven't already, head over to the Efinix website and download the latest version of Efinity IDE from the support section. I have already downloaded and installed it on my system, so let's just jump straight into the software. So you have these FPT software tutorials here. You can refer that on the website, and you have FPT software user guide and everything here. You can refer all this. Since we are using a Titanium interface user guide, we will just start to write a simple logic Verilog code, system Verilog. So we'll create a simple design. First, we'll create a project and ready demo. We'll select the board. Art is generator. So we'll create the immediate demo. Our Verilog code is very simple. It just simply connects the push button input directly to the LED output. In other words, whatever the logic level appears on the button, it is immediately reflected on the LED. So now we have to open the tools and open interface designer. Now we have to describe our physical pins here. So we'll create a GPIO block, name it as button, and LED. So LED is output, so we have to change it to output. We will assign the resources here. We have to search it in the user guide. So we will search it here. User LED. We have 6 user LEDs. We can use anything we want. I'm going to use the first user LED GPIOB1. We'll go back to the interface designer and assign it. And for user buttons, GPIOB113, we use this, SW3. So click on check design and it will generate interface output files. So these are done now. We'll use Efinity software now. We'll start the flow from synthesize. Our bitstream is generating right now. So let's check control. You can see resource summary. Nothing is there because this is a we don't use any flip-flops or anything. We're just directly assigning LED to button. So now we'll open the tools and open programmer. And you can use JTAG or SPI active. If you are going to program the flash memory, then you can use SPI. But we'll just use the JTAG. Choose the bit file and now click on the start programming here, button here. uh, device is in user mode now. That means that our board is programmed. We'll check it. Now, if you check the board, you can see that if you press the button SW3 button, you can see that the LED goes off. I have already told you that the user button is active low. So that's it. Our first design is done. And next, we'll try to make the LED blink with clock. So for that, we'll go back to the same file. You'll create a clock. You put the clock. Always clock. Always alt. Positive edge. We will use this 50 megahertz clock resource. So we are just, there is no difference between the previous code and this code, but the only difference here is we are using a clock. Whenever the clock is high, the LED button, LED will take the input of the button. So, but for generating a LED blink, we need to know how this clock is working. So, if this clock is at 50 megahertz, we have to divide the clock. We should make a counter and we have to divide the clock and we have to make it blink for 1 second. For that, what we do is we will declare a logic counter. 25, the size is 26. And then we will increase the counter. Our clock is 50 megahertz, so we are using if counter equal to 50,000 megahertz, 7 zeros. Then begin having some error. I think we don't need the button here. Actually, it's a good habit to use simulations tools and writing test bench before writing the actual code in Affinity software. So now we'll go and check what resources are used. Then now we are using for doing counter, we are using 25 adders, 9 LUTs, and then 47 flip-flops. This is you can see the resource summary here. We'll open programmer and try to program the board. Our board is programmed. We'll check this out. You can see that the LED2 is blinking for 1 second. And that's it for today. We have introduced the Titanium Ti180 M484 development board, verified the hardware, and taken a quick look at the Efinity IDE, created our first FPGA design. So today's design was very simple. In the next part, we will move beyond simple GPIO examples and we will start with working with one of the most commonly used interfaces, UART. We will build the design step by step, understand how UART communication works, and interface the FPGA with PC. Thanks for watching, and I'll see you in the next one. And also, if you want any resources, you can refer their website, Efinix website, for additional information about the tools we are using. You can find user guides for interface designer, programmer, debugger, everything in the website. So thanks for watching, and I'll see you in the next one. Bye.